Okay, guys. Hope you had a good break. Short, but here we are. Right, we obviously starting a new chapter today. It is trig, but it's very different from the trig that we did last term. This is all, yeah, it's basically solving triangles. All right. I'm going to teach you 3 new rules: the sine rule, the cosine rule, and the area rule. And those are 3 rules that you can use in triangles that are not right angled. Okay. First, we're going to just revise how we solve right angle triangles. That's stuff that you did in grade 10. So the first section here is actually a grade 10 revision. Solving right angle triangles using trig. Yes. So we use on yeah, really different chapter. It does have some trig in it, yes, but you'll see that it's quite different from the stuff that we've done so far. Yes. Only 2, so it's this, and then we're doing functions. Functions, which is graphs, parabolas, hyperbolas, that stuff. Okay, guys, I'm hoping that you remember that in a right angle triangle, we can use Pythagoras. Yes? Does it ring a bell? Hey, Pythag? Remember, you can only use Pythag in a right angle triangle. Okay? So let's write this on the side. We can use Pythagoras, obviously, to find the length of a side. But then in a right angle triangle, we can also use our 3 trig ratios that we've learned. Now, guys, in grade 10, you did 6, all right? You did the reciprocals as well. You did sec, cosec, and cot. Remember that reciprocals, the other 3 are out of the grade 11 syllabus. Okay, so we're only going to work with sine, cos, and tan. So let's just revise those quickly. Sine of theta is always opposite over hypotenuse. All right, cos of theta will be adjacent over hypotenuse, and then tan of theta will be opposite over adjacent. So those are the tools that we can use to solve sides or angles in a right angle triangle. Okay, we can only use those if it is a right angle triangle. Right, we're just going to do some examples, guys, so that you can remember what we did last year. That over there is a lowercase c, and that's a lowercase a. All right. So we're going to have to find those lengths. Right, guys, they're just saying that we need to find the sides of the unknown sides and angles. All right, now if we're looking at that triangle, do we notice firstly that it is a right angle triangle, right? So we are allowed to use pi side, and we're allowed to use any one of those three trig ratios or multiple ones if we want. Okay, but guys, isn't it easiest to find angle A first? Right, we have two of the three angles in that triangle. Yes? So how are we going to find angle A? By saying 180 minus 90 minus 35. All right, so angle A, let's write it on the side or underneath if you want. And you don't have to show the step where you are subtracting, but I'm just writing it down in full. If we are using that, we always have to write down a reason. What is the reason? Angle sum and triangle, good. What's 180 minus 90? 90 minus 35? 55, hey? You can use your calculator also, it's fine, doesn't matter. So A is 55 degrees. All right, so we can fill that in once we've calculated it. That's the first one done. Now we need to find those sides. Now guys, the only way for us to use Pythagoras is if we have two of the three sides already. Do we notice that in this triangle, we only have one of the three sides? So we can't actually use Pythag, right? We're gonna have to use Trig. Now, there are multiple ways in which you could do this. Let's say we're working with the 35 degrees. Okay, you can work with the 55 as well, but let's work with the 35 degrees. Which one do you guys want to find first, A or C? Okay, we can find C first, all right? So what you need to do is you need to look at the angle that you have. Do we notice that C is the opposite side to that angle? And what is the side that we have? The hypotenuse. Guys, which trig ratio works with opposite and hypotenuse? Sine. So that is what you're going to use. You're going to say sine of 35 is equal to opposite, which is lowercase c, over hypotenuse, which is 50. Right, so when you're using any one of those three, okay, 50 centimeters. That's fine, it's a cool. No worries, it happens. 50 centimeters. All right, guys, that's what you have to do. Okay, for these trig ratios, you always need an angle, and then you have to have two sides there. All right, one of the two sides is the one that we're trying to find. Okay, so you need to look at your angle. The one that we're trying to find is the opposite side. The side that we have is the hypotenuse. So then you look at your three trig ratios. Which one works with opposite and hypotenuse? Sine. So that is the one that you're going to use. Okay. If you wanted to find A first, you could have said that if we have 35, A is the adjacent side. We have the hypotenuse. Which trig ratio works with adjacent and hypotenuse? Cos. So we can use cos to find that one. Okay. So like I said, there are multiple ways in which you could do this. Now, guys, if we need to find C, we need to get C on its own. What am I doing with this 50? I am dividing by 50, right? I have C divided by 50. So when I move it, I'm going to have to multiply by 50. I'm just going to write my C on this side. So this is basically what we are doing. Or if you want, you can just write it like this. Sine 35 times 50. But guys, if you type it into the calculator like this, it is very important that you close your bracket after the 35. Okay, when you type sine, it opens a bracket automatically. Then when you do your 35, you need to close the bracket and then times 50. Okay, otherwise it's going to say that it's sine of 35 times 50, that angle. Okay, let me just get my calculator quickly. Okay, so like this, you would have to say sine 35 close bracket times 50, and then you'll get your answer there, or you can do 50 sine 35. In that case, you don't actually have to close your brackets, you get the same answer. Okay, so let's round to 2 decimals, 28.68. And we are working in centimeters. Okay, now to find A, that's the last thing that we need to do. You have two options now. You can use Pythagoras, right? Because we now know that C is 28,68. So you can use Pythag. Remember, if you're finding A is not the hypotenuse. So you're not going to add these two together. If you have the hypotenuse, it's always hypotenuse squared minus the other one squared, right? We'll give you A squared. So let's practice that. So A squared is going to be 50 squared minus 28.68 squared. And you have to write your reason of Pythagoras, please. Now, guys, here it would be okay if you work with this rounded value because this was actually an answer. All right, this was one of it's like a final answer. We actually have 3 final answers in this question because we have to find 3 separate things. So it's okay if you type in 28.68 squared, but it's also fine if you just keep it in your calculator and you work with the unrounded thing. Okay, there will be 2 answers on the memo, yes? You have to write the whole thing. Yeah, unfortunately, that's what it says on the reason sheet. Okay, so 50 squared minus, I'm just going to type answer squared here, and you get that. For A squared, it might be slightly different if you just typed in 28.68 squared. That's fine, don't worry. 1677.525 and then blah, blah, blah. But obviously that's A squared. We need to now find the square root. Now, guys, here you're not allowed to round. Okay, because this is an in-between step. Here you have to work with the unrounded answer. Okay, so square root answer, 40.96. Okay, if you work with just 28.68 squared, your answer might be slightly different. But like I said, that's fine. Or we could have used cos. Right, like I said before, I'm just going to write that down. Or you could say cos of 35 is equal to, remember, like we said, 35, A is the adjacent side, that is the hypotenuse. So you would say adjacent over hypotenuse is cos. So you would say A over 50. Could you use a different trig ratio? We have C, right? So we can actually use C as well. If I want to use C instead of this one, I could say that C is the opposite side, A is the adjacent side. Which trig ratio works with opposite and adjacent? Tan. So we actually could have used tan for this one as well. Hey, we could have said tan of 35 is that one over A. All right, you could have done that as well. Tan 35 is 28.68 over A. That one would be a bit longer to solve because now you're going to have to multiply the A out on the other side and then divide by tan 35, but you still get to the answer. All right, and then you could also actually work with 55 instead of 35. We've been working with 35 all the time, but you could work with the 55 as well. If you're looking at 55, you could say that A is the opposite side to 55, and then you could work with the hypotenuse. Opposite hypotenuse is sine. So you could say sine of 55 is A over 50, and then solve it from there. All right, so there are actually many ways in which you could find that last side. Is A over 50. Or tan of 55 is opposite over adjacent. Right, so you could use tan 55 for that one as well. Opposite is A over adjacent, which is 28.68. Right, it would be totally up to you which one you choose there, yes? For a question like this, we don't usually give a question where it's just find the size of all of them. We usually split them up into separate ones. but then it will probably be 1 mark for finding A, 1, 2 marks for that one, and then also 1, 2. Yeah, so it would be 5 marks for finding all three. Okay, let's look at another one quickly. Number 2. Are there any questions on that one, guys? The first, so angle A would be out of 1, I think. Just 1 mark for getting that. Oh, no, this is just a revision of last year's stuff. Yeah, sorry, we haven't learned the first one yet. Ask me if you can't read any of those values there. You guys want to find lowercase d, so long you can go for it. It's a right angle triangle. They've given us 2 of the 3 sides. Okay, so you can find that third one using Pythag. Do that on your own, please. Find d, which is the same as EF. All right, it's the hypotenuse, so you're going to add the squares of the other 2 sides together to get that one. Okay, that's what I got, 66.24. Anyone else? Yes. All right, so because it is the hypotenuse, you're going to have to add the other 2 together. Sorry, stumbling over my words there. So you have to say 32 squared plus 58 squared, or the other way around. It doesn't matter what order you add them in. Please remember to write Pythagoras. Guys, this step you don't actually have to write down. Okay, you don't get a mark for writing that down. You will get a mark for the first line and then for the answer. Okay, this in between step you don't have to write down. You can if you want to, obviously, but you won't be penalized if you leave that out. And that is in the value that you have to square root on the calculator, and that will then give you the length of lowercase d. Now we need to find theta, I would say. And then once we have theta, we can find E by subtracting 90 and that angle from 180. This one is a bit more difficult than the previous one. In the previous one, we had 2 angles, so we could just do 180 minus straight away. Now, guys, if you don't have either one of these 2 angles, you just have the 90-degree angle. You have to use trig to find one of your 2 angles. Okay, so you could decide to find E first. I'm going to find F first because that is the one that they put the theta in, but it doesn't actually matter. Okay, so we're going to look at this angle. Now, guys, we have all 3 sides, so we can actually choose which of the trig ratios we want to work with. If we're going to work with the 2 sides that were given, that's often the safest bet because you might have made a mistake here. Okay, it's actually best to work with the information that they gave you. So let's look at the sides that we have. If we're looking at theta, do we agree that 32 is the opposite side and 58 is the adjacent side? Which trig ratio works with opposite and adjacent? Tan. So tan of theta is equal to opposite, which is 32, over adjacent, which is 58. Now, how do I get theta on its own? Shift tan, right? This is now like we are calculating the reference angle in a trig equation. Guys, do we have to do like the general solution, do you guys think? If I'm working in a triangle, can I say plus 360n if I find my reference angle? Can I have an angle in a triangle that's like 400 degrees? No. Okay. So if this was just the question on its own, solve for theta, you would have to do your whole thing. Okay, it's positive in the first quadrant. I find the reference angle. Then I say in quadrant 1, it's the reference angle plus 180n. But because of this scenario, because we're working just in a triangle, right? We know that we can't have an angle that's bigger than 180 degrees in a triangle, all right? We actually can't have more than one angle that's 90 or bigger in a triangle, right? Because we're working in a triangle, we don't have to do the whole general solution thing, okay? So to get theta on its own, and these are the types of questions that you did in grade 10, where you don't even, remember in grade 10, you didn't even know about reference angle and general solution and all of that stuff, right? You just did shift tan and the value. Let me just write here, tan to the -1 of 32 over 58. You could also simplify this if you want, all right? That's not the simplest form, but you don't need to. Shift tan 32 over 58, and you get your answer that theta is 28.89 degrees. All right, so that is how you find an angle in a right angle triangle if you don't have other angles. Okay, we only have the 90-degree angle, but that's not going to help me. I needed to actually have that second angle in order to do 180 minus. Okay, so the other option is then to use sine, cos, or tan, depending on the sides that you have, and to then find that angle. Now, guys, if I know that theta is 28,89 and I have that 90, how can I get angle E? Angle sum and triangle. All right, so angle E is equal to 180 minus 90 minus 28,89. And you put your reason there, angle sum in triangle. And the answer is 61,11 degrees. Or we could have used trig, right? Which I'm sure you would prefer to just do angle sum and triangle. But if we didn't have that angle, for example, what if you wanted to find E first? You would say, okay, I'm looking for angle E. I have the opposite side and the adjacent side. So tan of E will be 58 over 32. And then you do your shift tan thing. Okay, so I'm just going to write that at the bottom here. Or tan of E is opposite over adjacent. So 58 over 32. And then from there, you would do shift tan of that and you'll get the same answer. Now, guys, since we had D, we actually calculated it. We could have used other trig ratios as well, all right? Not just tan. We could have used, if you're looking at theta, for example, if you wanted to use those two, we could have used cos of theta. We could have said cos of theta is adjacent over D, and then we could have solved for D from there. Or we could have said cos of theta, sine of theta is opposite over d, and then we could have found theta like that. All right, so again, there would have been multiple different ways in which you could have found these things. Does that make sense, guys? Are we okay with these kinds of questions? I'm going to give you a few now to just do on your own as well. Right, so we haven't actually learned anything new, right? This is grade 10 stuff. You are going to practice this now, please. So it is exercise 1 on page 215. I want to make sure that we are all fine with these types of questions before we move on to the non-right angle triangles. Okay, there are only 4. I'll put them on the board just now. There they are. Can you guys read that? Should I zoom in a bit? Oh gosh, what's happening here? Yes. There, and then there's one there. Okay, guys, I'm going to give you 3 minutes, all right, to start working on this. You might not finish, but then I want to do sine rule after that. Okay.
I tried to learn it one and then and I was like, I'm so watch the video. Sure. And then okay, I will do that. I'm saying I know it might take you some time, so don't feel a lot of pressure. Rather just stay on track with this stuff. Yeah. So you are holding on to Tuesday. Yeah. Cool. Okay, thank you.
Thank you. Let's not talk. Let's go. Okay, there we go. It's just this, and then we're using one example. Okay, so now we're going on to solving triangles with no right angles. So I can't use Pythag or sine or cos or tan, like actual ratios for those. For these types of triangles. And guys, the reason for that is just, I mean, if you don't have a right angle, you don't have a hypotenuse. Right? So you can't use sine, cos or tan if there's no hypotenuse there. Same for Pythag as well. If there's no hypotenuse, you can't use Pythagoras. Yeah, so you learned about the location. All right, guys, the important thing here is that sine rule, so I'm just going to add it here next to the heading, always works with opposite sides and angles. And this rule is something that you can use to either find a side or an angle. Like you can see here, I wrote that if you are finding a side, you're going to use it in that form. If you're finding an angle, you're going to use it in that form. Now, guys, let's just quickly revise the notation here. All right, I think you probably would just refer to this as BC. All right, if the diagram was given, you probably wouldn't think, okay, this is small a, lowercase a. All right, you would work with BC. That's fine, you can keep doing that. This is just the way that the rule is formulated, and it's the way that it is written on the matric formula sheet. Okay, so you do need to know it in this form. And what this is saying is in any triangle ABC, I would suggest that you not use this in a right angle triangle. Okay, you can, but because of, yeah, it can just complicate things a bit when you're working with sine 90, because what is sine of 90? It's 1, and then sometimes it gives you a strange answer. Okay, so people sometimes try and use sine rule with a right angle triangle. I would suggest that you don't do that. So what it says is that if you have a side, then you can put that side over sine of the opposite angle, and it must then be equal to any other side over sine of the opposite angle. All right, so they have 3 fractions here. When you are using this, you'll only work with 2 of them. Okay, you'll never work with all 3 of them. The formula is just saying that all 3 of these fractions will be equal. All right, but you're not going to work with all 3 of them at the same time. You'll see now when we do an example. So if you are finding a side, you're going to, or if you're trying to find a side, you're going to put the side that you're trying to find. Say we're trying to find side A, right? You're going to say side A over sine of the opposite angle. Obviously, you'll then have to have that angle. Okay, so sometimes you'll have to find it, but you'll say this side, the one that you're trying to find over sine of the opposite angle, is equal to any one of the other 2 pairs. All right, you can decide. If you have small c, side C, and angle C, you're going to work with side C over sine of angle C. All right, we are going to do an example like that now, so don't worry if you're confused. The other way around it also works is, so if you are trying to find angle A, for example, you're going to put sine of that angle, sine of angle A at the top, then you're going to put it over the opposite side. And that is then equal to any other pair that you have. All right, so say you have angle B, you're going to put it as equal to sine B over side B. All right, the side that's opposite that one. Okay, but like I said, you're never going to use all 3 fractions in one equation, all right, but all 3 fractions will be equal. Let's jump into an example quickly so that you can just see how we use this. And we'll just do one example for today where we are finding a side. We'll talk about finding angles tomorrow. Maybe we should label this as number 1 because we'll just do the second one tomorrow. If this doesn't ask you for angle A in this case, you don't have to. But if they did, you can have. Okay, guys, we want us to solve for x, which is this side. All right, so we're going to use the form of sine rule where the side is at the top. The only reason for that is so that our solving is a bit easier. All right, if our side is at the top, we just need to multiply the other side by the sine to get that side on its own. Okay, so do I have the angle that's opposite to side x? Yes. So that's going to be my one fraction. I'm going to say x over sine of 66. Do I have another pair of a side and an opposite angle? Yes. 15 over sine of 55. That's going to be my second fraction. I don't need the third fraction. I have enough information to solve for x like that. Okay, so we're going to say x over sine of 66 is equal to, so it's always a side and angle that are opposite to each other that form a fraction. Okay, those two are a pair, they go together in a fraction, is equal to our other pair that we have, 15 over sine of 55. To solve for x, to get x on its own, what must I do with that sine 66? I'm dividing by it on the left-hand side, right? So if I move it to the right, I'm going to times by it. So x is going to be equal to, now there are two ways in which you can write this. The first way is perfectly fine. But later on, when we work with variables, then I'll show you the second way will be better. Okay, but that is essentially what we're doing. We're taking the fraction and we're multiplying it by sine 66. But guys, do you agree that this is the same as sine 66 over 1? So I can actually put the sine 66 in the numerator, right? Again, it's fine if you write it like this, but later on when we work with variables only, okay, that is going to happen. We're not going to have any values, we're just going to work with variables. Then it will be better to write it like this. 15 sine 66 over sine 55. Right, we understand that those two are the same. Okay, if you multiply those two fractions together, you have 15 sine 66 at the top, sine 55 times 1 at the bottom. Okay, please type that into the calculator, guys. Let's see what we get for x. That is what I got, or the textbook got rather, 16,73. And that's it, guys. That's the value of x. That's the length of that side. Okay, so that is how you would use sine rule. Are there any questions at this point, guys? We haven't done using sine rule to find an angle, but we'll do that tomorrow. Okay, all fine. All right, please carry on with exercise 1. That is your homework for tomorrow. There are still 7 minutes left. I don't want people packing up, please. I don't want people backing up. I want you to carry on with that work, yes?
Where is the thoughts of
Well, we've done some with fixed stuff, but kind of in between other stuff. There is no like proper ending off of grade 11 and then grade 12. If I move it down, yeah, well now. Yes, yeah. All right, guys, carry on with exercise 1. Must I put it back up for you? Okay. There we go. There's exercise 1. Work please, work please. Thank you, thank you.